Hello all. Welcome to the video lecture on distance vector routing. This distance vector routing is a very famous one in early 80s. It is an iterative method of routing. This comes under the dynamic algorithm, whereas each router shares its own information with the neighbor router. So with that, calculating the cost value, they will be finding the minimal cost or the minimum hop that is required to reach the destination. So this is also known as Bellman-Ford algorithm. So these are all the inventors, those who gave this algorithm. So now we will directly go to the problem, where this is the problem that is being given to us, where we have 5 routers are here, A, B, C, D, E. These routers will be sharing their information between each other. Now we will just find the method or find the way how this distance vector routing is being formed. That is our first one. In the second problem, we will be seeing how the routers used to share their data and how the routers work. So first is that now we are going to form the routing table for B. For B, we are going to form the routing table. So for B, if we say B, for B to reach A, it costs 1. So that is what is being written. The cost is 1, and to reach the next hop is A. Right? Now, from B to C, it is going to be 3. Cost is 3. So it is going to reach C. Then from B to E, it is going to be 9. As shown here, this is going to be 9. Similarly, for reaching this D, B to D, what we have to do? We have 2 routes now. For that, we have 2 routes now. One is going to be, you can go from B, E to D. This is where you can reach, or else you can reach by B to C and C to D. By this method you can reach. So what we are going to do? What we are going to do is that we are just going to count the cost. So if we go in this way, the cost is going to be 11. 9 plus 2, it is going to 11. But whereas if we go in this way, it is going to be 3 plus 4, it is going to be 7. Hence, we are choosing the path which is 7. So this is how we are going to reach. See here, we have mentioned C here. For reaching D, we have to go next hop is C, then we are going to D. So this is how we are going to reach. This is the routing table for B. So this shows what are all the method, way, how you can reach. So I'll just go with this one. For going from B to A, B to A can be reached directly. This is the least hop count. Whereas B to A can be reached by B to C to A. We can reach by this way also. If we are going to reach by this way, automatically 3 plus 5 will be the hop count. Cost metric. So if that is going to be the case, the least is 1. That is why we have taken 1 here. Hope everybody understood the routing table for B. I'll just go for one more example for routing table of A. If we are going for routing table of A, for A to B, to reach A to B, the least path is 1. So 1 is given. So directly B it is. For reaching B to C, it is going to be 5. For reaching B to C, listen, for the routing table to reach from B to C, it is going to be 5. It is clearly specified here. But here is the point where we have to look. If we reach the same path by this method, that is from A to B, B to C, the cost is 1 plus 3. Automatically it is 4. So which is the most preferable is that it is not the direct path of A to C. It is the path of A, B and C. So that is why it is mentioned as C here. So on the way it is going to be B, right? This is how. Similarly for A to D, which is the best route. Best route is going to be, this is going to be the best. There are many routes we have, so we have to check. We can reach this A to D by A, C, D. This is one route what we can reach. And the next route is that A, B, E, D. This is the second route what we can reach. And the third route is going to be A, B, C, D. So this A, B, C, D, if you look here, this is the shortest path. Look here, 1 plus 3 is going to be 4, then 4 plus this is going to be 8. So that is why it is mentioned as 8 here. Similarly, for this A to E, the shortest path, if we look, this is going to be, if we go by A, C, D, E, automatically it is going to be 11. But when we go via A, B, E, it is going to be 10. That is why it is mentioned as 10. Now, the routing table of A is going to be 0, 1, 8, 10. That is being mentioned here. For A to A, obviously it is 0, 1, 4, 8, 10. Similarly, we have written for B. We shall just check it out. 1, B is going to be 0, 1, 0, 3, 9, 7. So look here, 1, 0, 3, 9, 7. This is how we will be finding the distance vector routing. So if we have similarly we have to do for C, and similarly we have to do for B, similarly we have to do for E. This is how we will be forming the table, distance vector table. Let's see in the next example. Thank you.